Hi class, we are back with another video. Today we are going to be discussing chapter 7.2, the law of signs. So we're going to have a description of what we call the ambiguous case and solutions to SSA triangles. Right. So in the last video you guys had for 7.1, there was two other cases. SSA was not one of them, so we'll be discussing the SSA triangles. And then we'll analyze data for possible number of triangles that we have for the law of signs case. So the description of the ambiguous case. So if we're given two lengths side side and the angle that's opposite of one of them, that's the A, then we may have 0, 1, or 2 triangles that satisfy those conditions. Okay, so that's why it's the ambiguous case, because it may not be that there's only one triangle for us to use the law of signs on, but there may be none, only one, or there may be even two possibilities for the kinds of triangles that we can construct that satisfy the condition of the SSA that is given to us. Okay, so let's go ahead and work on this, right? So if our angle is acute, then there are 4 possible outcomes. So first off, let's say that there is no triangles. Okay, what would that look like? Okay, it would look like this. So our side that is opposite the angle A is too short to reach our end leg, basically. Okay, so if we try to apply the law of signs, we're basically going to get an angle, or I'm sorry, not an angle, but a ratio for this angle B that would be here that's larger than 1, which we all know is not possible, right? The largest that sign can be is 1. And the value of the height here would be in between the length of A and the length of B, the two legs that possibly would have been able to occur, right? So this is not a triangle, so there's no triangles if this is the case, right? So this is what happens, again, when we try to apply the law of signs. Okay, so let's say that there's only one, right? A unique triangle. And this is the case that we get. If you notice, we come to a right angle here, right? So here, the sine of B will equal 1, okay, because it's a 90-degree angle. My A is the same as the height of the triangle, because it's the height. And the height is going to be less than B, because B is the hypotenuse, it's the longest side. This is kind of what we're used to working with, right, in our right triangle trigonometry that we've been developing. The next case is, again, another version of a unique triangle. Okay, so here our side A is looks like this. I guess that's the easiest way to say that, right? So our conditions then is that B is less than 1, right? So for the 3 so far is that it's larger than 1, which is not going to give us a triangle. B is equal to 1, in which case A is the height. Sine of B is in between 0 and 1. In that case, A is longer than B, but it's not going to be the longest side. Okay, right? And for the next part, for 2 triangles, here we kind of have a mixture of things that are going on, right? So here you can see that B1 and B2 lie on a semicircle radius A, okay? And both of those connect to the length of the side C, right? So here, sine of B2, if we're looking at this triangle, is less than 1, larger than 0. And A is going to be in between the length of the height, so it's larger than the height, obviously because it forms a right angle here. And it's going to be less than B because B is the longer side in this case. Right, so then this is the second triangle that we can discuss, or that we can construct. Okay, so that's a nice little diagram here that'll help us. Obviously this should be in your textbook as well. For the next little diagram we have, let's say A is obtuse, right? So again, this is when the angle A is less than 90 degrees. And then when it's larger than 90 degrees, we have 2 cases, right? So one is, again, that we can't form a triangle. Here, the side is not going to be able to reach the edge, right? It's not coming in at an angle long enough for it to, even if it was down here, right? Let's say it went too far and it's not able to reach this side. It's either too long or too short, right? It's not going to create a triangle, okay? So applying the law of sines here again, the sine of b is going to be larger than, in this case, or equal to 1. And here, our length of a is going to be shorter than this length of b, or equal to it. It doesn't really matter, right? This next one, here it is going to be long enough, and we'll have an obtuse triangle, okay? Here a is longer than b, right? And the sine of b is in between 0 and 1, right? So those are the possibilities for the triangle. So do you have to remember this? I mean, no, right? I wouldn't say so, but you know, just being aware of the types of triangles that can be made is important, right? So just remember the possibilities. So applying the law of sines. So again, right, the law of sines is that sine of a over a is equal to sine of b over b is equal to sine of c over c, right? So very standard, easy rule to apply. Once you have the angle of one of those known, then you apply that equality to find the rest of the values of your triangle, right? So let's talk again more about applying this, right? So for any angle theta, the sine of theta needs to be in between 0 and 1, okay? If it's equal to 0, that basically means you have no height, something is 0, right? So you don't actually have a triangle, so it has to be larger than 0, and it can be equal to 1, but it cannot be larger than 1. If you look at these, every time we have no triangle, sine is larger than 1, right? No triangle, sine is larger than 1, right? Sine here is never equal to 0, obviously, because then you would have no triangle, just basically some sort of a flat line, okay? If sine is equal to 1, then your angle is 90 degrees, right? And you're looking at the right angle, right? So the triangle is a right angle. Sine of theta is equal to sine of 180 minus theta, right? So this was an identity we had way towards the beginning of the semester, okay? And so it's basically saying that supplementary angles have the same sine value, right? So a supplementary angle, right? So if this is 30 degrees, then this is going to be sine of 150, right? So you're just basically looking at the angle on the other, a quadrant over, right? This is really about reflectiveness, right? For 3, the smallest angle is opposite the shortest side, okay? The largest angle is opposite the longest side, and the middle valued angle is opposite the intermediate side. So that's a nice little fact to remember. And again, this is assuming that all the sides are not equal, okay? Okay, so let's go ahead and try an example, right? So example 1, solve the triangle ABC if B is 55 degrees, 40 minutes. Side B is 8.94 meters and side A is 25.1 meters. So again, we're not really 100% sure if what the case is, right? So here our angle of B is acute, but that doesn't tell us what's going on with A in this case, right? So if you remember, all of our things here were for what's going on with A. Is A obtuse or acute, right? So what exactly is going on with A? But I do know that I have B here, right? So I need to talk about A, I need to talk about B. C is kind of irrelevant because I don't have any information here for C. So when I set up my law of sines, I'm going to use sine of A over A equals sine of B over B. That's going to be the most useful thing for me to use at this point. Okay, so I don't know sine of A. Okay, so I can't talk about if it's acute or obtuse or anything like that. Okay, so I have B, I can plug that in. I have all these other values, so I can do, I hate to say this word, but the cross multiplication to solve for sine of A. Right, so I will plug in the things that I do have, and I will basically multiply both sides by 25.1. Obviously, I would like to find this value, although I don't necessarily have to find that value just yet, right? So I have this set up for my equation, I can plug all of this in, and notice I get a value that is larger than 1, meaning this is not going to form a triangle, right? My A is, in this case, would be something like this, right? But I have a sign value that's larger than 1. That's a 0 number of triangles sort of situation, right? Sign value larger than 0. It's not allowed. That doesn't happen. So there's no triangle for me to solve here. Okay, this is impossible. No such triangle exists. So let's now move to see what would happen if I tried to sketch this, right? So let's go back to what we're here. Okay. So either I'm going to get this sort of situation, or I'm going to get this sort of situation. I can figure this out. Obviously, I can try to, my B is acute, so it should look something like this, right? Because here the values obviously are switched up a little bit. So I should get a triangle that looks something like this case, right? Let's come back here. Okay, so this is 55 degrees, 40 feet. Here you can see that the side across it is very small and A is very short. So, or I'm sorry, opposite of that, this is very long and this is very short. So the side across from this angle, the acute angle, should be small, right? So that should look like this. This would be my B. This would be the short little B that goes with it. This would be my angle A, right? And then this would be alongside A that's given. Yes, we can jump straight to this. Okay, so it'll look like this, right? I got an angle, I got a side and a side. So remember, the two sides are together, and then the angle is given after it. Side, side, angle. This is not gonna work, right? However it is that I need to draw this, that's why it's on a swivel here, right? As a radius, from with this being the center, with a semicircle, it can kind of go anywhere. It doesn't really matter because it's not going to form a triangle. Okay, so note that in the ambiguous case, we're given two sides and an angle opposite one of the sides, right? So two sides, and one of those sides is opposite the angle, right? Example 2. So let's solve the triangle ABC. If A is 55.3 degrees, A is 22.8 feet, and B is 24.9 feet. So here again we have A and B, so we're going to use sine A over A equals sine B over B. We know information about sine A, so same thing, we're going to plug in the things that we can figure out, which is sine of A, we have B, and then we'll try to solve for sine B just to check to see if this is something that we can actually work with, right? So we clear everything out so that we have sine B alone. This is in between 0 and 1, so we're all good. A triangle exists, okay? Now we need to figure out what kind of triangle. So again, A is acute. So if a triangle exists, there's either 1 or 2, and even if there's only 1, there's 2 options for the 1, right? So there are 2 angles between 0 degrees and 180 degrees that give us a value of sine B, right? So there's one in the quadrant 1, and there's one in quadrant 2. Okay, they are supplemental to each other. Okay, so one of those is 63.9 degrees, which is easy to find if you use sine inverse, and the other one then is 180 minus 63.9, which is 116.1 degrees, right? So those are 2 options. Okay, so let's assume, let's try to solve a triangle for both. Possibly one of them will fall out and there's only one case, or it'll work for both and then we have those 2 cases, right? So that's kind of how we figure out whether or not there's 1 or there's 2. Okay, either one falls out and it's not possible, or we can do both of them at the same time. So let's say we have A plus B2 here. We're separating the first option and second option. Okay, so then that'll give us 55.3 plus 116.1, which is 171.4, so that's under 180. So that means that our angle of C would be extremely small, right? Less than 9 degrees. So it's a valid possibility, although I would assume highly unlikely. We still have to check it out. Okay. So we're going to solve two separate triangles, right? So AB1 will give us one option. AB2 would be 55.3, 116.1, and then an angle C2 of 8.6 degrees. AB1 will give us different options. We would have 55.3, 63.9, and then 180 minus those would be our C1 for that triangle, right? So we want to put those things together, okay? So we basically want to see, can we work both? Are both options valid? So for A1, or I'm sorry, A, B1, C1, because A is fixed, it's not changing. We have options for B1 and C1. A is 55.3, B is 63.9, that first choice that we had, right? And then C will be 180 minus the sum of A and B, okay? A is 22.8, B is 24.9, C1 would be 180 minus these two, right? Because the triangle has to be 180 degrees, and that's 60.8 degrees, right? So if we use this relationship, right, from the law of sines, we have these relationships because C1 in that case would be the only value that we don't know, okay? We will have, if we solve for C1, right, multiply both sides by its sine, 60.8, I'm going to have 24.2 feet, okay? So now everything is solved for. I have angle A, angle B, angle C, and I have side A, side B, and side C, right? So for the acute possibility, I have everything solved for, right? So now we got to look for the obtuse option, right? So A is 55.3, B was this 116.1, A was 22.8, B was 24.9. I talked about how to find C already, right? So it's going to be about 8.6 degrees because that's what's left over from 180. Then using this relationship, we'll solve for C2 in much the same way, right? So, and again, it doesn't matter if we did it this way or sine A over A and sine of C over C, but we'd have to do a little bit more manipulations if we had the A and the C on the bottom instead of on the top. Right, so having the sides on the top allows us to do just one simple clearing of the fractions on one side to get the side alone. So that's why we're using the reciprocal portion of this identity and not the sign on top and the side on bottom. So solving for C2 gives us the following, which is 4.15 feet. So for A, B1, C1, it would look like this, almost isosceles, because this angle and this angle was very, very close. And then for 2, we have this, so we actually have two possibilities, right? Ambiguous case of two triangles. So, the number of triangles satisfying the ambiguous case, side angle. So let side A and side B and angle A be given in triangle ABC. Okay, the law of sines can be used to calculate the value of sine B, as we've seen, right? So, if applying the law of sines results in an equation having sine of B being larger than 1, there are 0 cases. Okay, then no triangles can satisfy that because that's not possible, right? If sine of B equals 1, then we have the right angle, and there's only a single solution to that. Okay. If sine of B is in between 0 and 1, then we have either 1 or 2 triangles that satisfy the given condition, right? So for the first part, if sine of B is K, and we let B1 be sine inverse of K, right? So with the angle, and we use B1 for B in the first triangle. And then we try to use B2 as 180 minus B1, right? So the last example we had, that's what we did. We find the supplemental angle, right? If A plus B2 is less than 180, then there's going to be a second triangle, okay? If if A plus the second angle, that supplemental angle is more than 180, then obviously we're not going to have any options, okay? So this is our last example. So this is probably going to be the case where nothing works. We actually got one more example after this. I'm sorry. So let's go ahead and go through that one more time, right? So we have ABC. So let's say A is acute for 3.5, A is 10.7, C is 7.2, right? So we have no info for B, so we're going to use the law of sines to find sine of C. If it's larger than 1, nothing exists. If it's less than 2, we move on to the next. If it's less than 1, we move on to the next case. If it's equal to 1, we know there's exactly one solution, right? So we solve for sine of C. We clear everything out, plug the exact value into our calculator, and we have a small value. So we find out the angles that work for this, right? So we find the first one that's in quadrant 1, which is 27.6. You can use inverse sine to find that value, right? And so its supplemental angle then is 180 minus this value, right? So 152.4, something to that effect, right? 152.4 degrees. Okay, so those are our two. So now our next check is it possible to have this angle plus this angle be less than 180, right? And from a quick check, you can see that that's not possible, right? We're going to have 150 plus 40 already is 190. We're not going to have, there's too much, right? So there's no triangle that's going to work with the supplemental angle. So that means we only have one option available, which is the 27.6. Okay. So since C is less than A, hold on. Okay, so this is from what we were given. Okay, this is what we found. 7.6. We're given 43.5, 10.7, 7.2. Right? Side, and angle. We found this other angle. So there's only one angle that's going to work here. So we find that 180 minus the sum of these two. Okay. C is less than A in this case. So C must have a measure that is less than A. And that's coming up from way up in the previous slide. So I'll go straight to it instead of going backwards, because I found that my screen tends to jump around when I do it the other way. Okay. So we are in one of these cases. Okay. It has to be this one because B is not equal to 1, right? We don't have 0, we don't have 2, we have one triangle, and it's not the sine equals 1 option, it's going to be this option, right? So obviously things are moved around a little bit, right? I believe it was A, this was B, and this was C for our triangle. Things tend to move around depending on how you draw them, right? So since I'm looking at C, right? So here we replace all of the B stuff with C's, because here I'm given B. So here my C is less than my A, right? So this is going to be my C, and this is going to be my C. So this is the triangle that I will be using. Okay, so back to where we were, right? This was C, this was C, right? As I said, they were kind of moved around. So C is less than A, right? So this side is less than this side, which is true. It's already given to us, right? 152 degrees is not possible, right? I found that here. That's not going to work, okay? Because adding these together, it's going to be over 180. It's not going to happen, right? So my B in this case has to be the difference between 180 and the sum of these two angles, right, which is going to be 108.9, right? So we're going to use this form of the law of sines because the only thing we have left in this case now is b. Everything else is solved for. I know the angle of b, I don't know the side of b. So this little b is the only thing I need. So I'll keep it in the top position. So we'll use the reciprocal of the identity. That way when I plug in all these values, I can multiply by sine of b and just have one thing here, right? So I plug my stuff in. I move this over. Again, I'm not actually calculating the values of any of these things until the very, very last step. So that way I do not get a rounding error, right? So everything has just been moved around, and now I plug this into the calculator exactly as one thing to get as accurate of an answer as possible, and we get side B is 14.7 inches. Okay, so then now everything is solved for, right? So our last example, okay, trying to analyze without or involving an obtuse angle. So without using the law of sines, we want to explain why a triangle with A 104 degrees, A equal 26.8, and B 31.3 cannot be valid for a triangle ABC, right? So let's talk about some of the things that we were using before. Let's do this without the law of sines, but we can still use the information that we had before. So we're going to try to minimize the number of calculations that we had. So let's see, all right? So here A is obtuse, okay? So we had a couple conditions for obtuse. Okay, this is what our diagram for obtuse looked like. So we know that we have an obtuse angle, and we're trying to satisfy the conditions for this, right? For no triangles, but we're not trying to use the law of sines. I'm sure we could take the sine of one angle, but that's not going to really work for us because we have to do law of sines to find that. So let's look at what we have, right? So we have an obtuse angle. We're given side-side angle, and it looks like for the angle that I am looking at, right, the one that I'm given is less than, the one that is opposite of the angle that I'm given needs to be less than the adjoining side, right? That's what I need, right? Because it's obtuse. If the side opposite my obtuse angle is less than the adjacent side to my obtuse angle for side-side angle, that's the condition I need. Obtuse angle, angle opposite, angle adjacent. My opposite side, sorry, not angle, side, right? Obtuse angle, the opposite side is less than the adjacent side for side angle. Okay, so we'll write that out so it's written out, right? So because A is an obtuse angle, it must be the largest angle of the triangle. So the side that is across it must be the largest side, which is not true here, right? Thus A must be the longest side of the triangle because it's across from the largest angle, right? But we're given that a different side is longer. So there's no such triangle that exists, right? You can't have more than one obtuse angle in a triangle. It's never going to work out that way, right? And there we go, right? And that's the last example. Hope this video was helpful. See you guys on the next one.